The Transistor Transformation of Electronics by Mark Goodale. The idea of the transistor was formed by William Shockley in 1945. He created the junction transistor and the point-contact transistor and thought it the idea for a solid-state transistor, that is, a transistor that is all in one piece of silicon or germanium. He thought that if you created a strong enough electronic field nearby a semiconductor, it would cause a current to flow through the circuit. His first attempts failed, but in 1946 William Shockley invented the improved design and created the first basic solid-state transistor at Bell Laboratories in New York State. It wasn't just Mr. Shockley, though. Co-inventors include John Bardeen and Walter Brattain, just to name a few. The significance of the transistor was apparent immediately. The need for a new communication system and for computers was incredible, and it seemed that nothing would ever be able to solve the problems of the vacuum tubes, which had very real and very problematic limitations. But the transistor was just what the electronics department needed. It was reliable, had few limitations, and could be used in a more efficient and faster way. The first transistor was just under 1.5 inches tall, which seems giant compared to today's transistors, but was actually quite small compared to the unreliable 3 to 10 inch vacuum tube.
The integrated circuits that are being made today in today's microprocessors have millions and probably closing on billions of transistors etched onto a single integrated circuit. And it's amazing how they can keep reducing the size of things. They're bumping into people who manufacture wafers like that, are bumping into the limits of physics, where the conductors that need to carry the electricity are getting to be about the size of atoms, and they're having trouble making it smaller and smaller. So we're trying to invent new techniques for increasing transistor density. Smaller. The atoms are getting in the way. Yep. It's been like that for maybe 5 years or so, and they keep making little steps for making the chips denser and denser, but eventually they'll bump into that limit.
Just a few weeks later, Mr. Shockley got a job working at the Central Lab division of Global Union in Milwaukee, working on condensing and miniaturizing circuits. There he finished perfecting his design and created the most improved solid-state transistor, thus revolutionizing the electronic industry, through a sort of electronic revolution. On November 17, 1947, Walter Brattain and John Bardeen discovered that when electrical contacts were put in contact with a germanium crystal, it increased the output power so much that it was greater than the input power. When Mr. Shockley saw this, he devoted his next 3 months to expanding the knowledge on germanium crystal technology. He soon discovered that by using germanium in a transistor, you could increase the total power. The downside to this was that it did not increase the processing ability. According to a recently conducted survey at Cable News Network, or more commonly known as CNN, they said that the transistor was the, and I quote, most important discovery of the 20th century, close quote.
Most of the devices, if not all of the devices that people are using these days, things that were electrical or mechanical, now have semiconductors in some form in them, usually as transistors, sometimes as more complicated integrated circuit devices, or sometimes full-blown computers.
You can see this in almost anything we use. A cell phone, still powered by vacuum tubes, would be over 10 feet tall, would not function nearly as well as a standard-sized cell phone, and would not last as long. Professor Jim Buffenbarger said, something comparable to the power of a laptop, when used with vacuum tubes, would be the size of a large house. Without transistors or semiconductors, we would not have any handheld devices, like calculators or cell phones, would quite simply not exist. The transistor is the most important invention for 3 reasons. 1. Efficiency. The transistor is more efficient than the vacuum tube in 2 ways, the first of which is lifespan. The vacuum tube's lifespan was no more than a few months in the best of conditions, whereas the transistor's lifespan can be anywhere from a few years to a few hundred years, depending on the quality of the transistor. The second and last reason is financial. A vacuum tube nowadays can run for either $10 to $15. A transistor microprocessor will run for the same. The difference is, the microprocessor has millions of transistors, so the price rate literally is 1 million to 1. The reason for such a drastic price difference is the ability for microtransistors. It is quite possible to put a few million transistors on something half a centimeter square, in other words, a small watch battery. The reason for being able to have such small devices is because of the size difference in silicon chip engineering. In silicon chip engineering, 1 meter is almost infinity, so instead of having a transistor equivalent to infinity, we use the micrometer, 1/1,000,000th of a meter, which is also equal to 1/1000th of a millimeter. In other words, the size equivalent in chip engineering is more than 100 millionths of a vacuum tube size equivalency, thus resulting in the drastic price difference. The second reason for it being the most important invention is manufacturing ability. 75 years ago, the U.S. produced just over 1 million vacuum tubes a year. Since the conversion to transistors, the U.S. now produces more than 1 trillion transistors a year, just under a quadrillion in the entire world. The reason why we are able to create so many transistors is for 2 reasons. Cost and ability. Like previously mentioned, the cost of transistors is less than 1/1,000,000th of a cent. Being able to produce over 1 million transistors for less than $1 results in being able to produce an abundance of this product at virtually zero cost to the manufacturer, thus producing an industry where it's easy to create a vast amount of product. Also previously mentioned, the ability of transistors far outweighs that of the vacuum tube, therefore making people want to produce transistors and making it worth the effort. And when you have a workforce that wants to produce a product, that product tends to be produced faster and without error. The third and final reason for the transistor being the most important and useful discovery is processing ability. Allow me to start with the processing ability for vacuum tubes. The vacuum tube could process, say, 100 web page links in 1 to 2 seconds, which, although that sounds fast, when your computer opens up a search page, it says something to the effect of 1 million pages found in 2.5 seconds. That is much faster, but it's even faster than one would think. Like previously mentioned, the transistor measures time in microseconds. So essentially, it is 1 million pages found in 2.5 microseconds, therefore making it 1 million times faster than one would have previously thought. So again, the transistor literally is 1 million times faster than the vacuum tube.
The computers these days are running at clock speeds of 2 or 4 billion cycles per second, so they're extremely quick.
The problem is, computers aren't getting any faster. It's just not possible.
And you can see that in today's computers that they're not getting faster and faster anymore. They've kind of topped out at 2 or 4 gigahertz, 2 or 4 billion cycles per second, and instead of trying to make them faster and faster, which they can't do, they put multiple microprocessors in a single computer.
But even though they can't get any faster, if it were not for the transistor, computers would still be powered by vacuum tubes, which would cause them to be huge. And if one vacuum tube burned out, the computer would stop functioning completely, and you'd have to check the thousands of vacuum tubes until you found the one that burned out. Searching for that particular vacuum tube would be like searching for a specific rock in a gravel driveway. If not for the transistor, we would have many more weather-related deaths due to not being able to predict natural disasters and warn people. A hurricane in the Gulf Coast would not be picked up by a vacuum tube computer. Before the vacuum tube, there were only computers such as the ENIAC and the UNIVAC, which could only do as much as a cheap calculator, but were over 3,000 cubic feet large. If not for this amazing invention, we would still be stuck in the dark age of electronics. The transistor is the most important electronic innovation ever.